we are at lesson 2.6b, writing equations of parallel and perpendicular lines. So we've already talked a little bit about parallel and perpendicular lines earlier in this chapter, and you can use the slope-intercept form or the point-slope form to write equations of parallel or perpendicular lines. We've already done this for equations in slope-intercept. Parallel lines have the same exact slope. So let's list some lines that would be parallel to y equals negative 3x plus 1. So if it's the same slope, I could say y equals negative 3x, right? Or I could say y equals negative 3x plus 1,000. Y equals negative 3x plus whatever you want except for 1, because plus 1 wouldn't be parallel. It would be right on top of the other one, and parallel lines do not touch. All right, so step 1, I want us to be able to write equations of parallel lines. Your step 1 will be to identify the slope so that you know what you need for your equation, because the other line should be parallel to it, should have the same exact slope. Then you're going to plug the slope in for m and the point given in for x1, y1, and you'll solve the equation for y. So this is what these will look like. It says, write the equation, or write an equation of a line that passes through this ordered pair and is parallel to y equals 1/2 x plus 3. So in this, it's a little tougher to recognize, but you are given a point and the slope. When you're given the point and a slope, that means that point-slope form is where you want to start with this. All right? So here we go. I said step 1, identify the slope. So your slope is 1/2, right? All right, so y minus y1 is negative 2 equals the slope times x minus x1, which is 6. Okay, so now I want to write this, and all these I want them to be in slope-intercept form. So moving along, I need to distribute. Y plus 2 equals 1/2 x plus, and 1/2 times negative 6 is negative 3. I'm going to add a negative 2, combine like terms, and I get 1/2 x plus negative 5. So, looking back, those equations would be parallel, right? They have the same exact slope, except this line right here is going to contain that point in it. So those two lines would be parallel, and that would be one of the solution points to this line. All right, let's try one more. It says, write an equation of a line that passes through the point 1, 2, and is parallel to y equals 5 minus 3x. So right here, your slope, 5 minus 3x means that's a negative 3. And this, of course, is your x1, and this is your y1. So we're going to start off with point-slope form because we're given the slope in a point. So I'm going to take y minus y1 equals the slope times the quantity of x minus x1. And we're going to rearrange this. So y plus negative 2 would equal negative 3x plus a positive 3, because a negative times a negative is still a positive. Nothing has changed about that, and it never will. I'm going to add 2, and y equals negative 3x plus 5. And again, it would be parallel to that original equation because they both, actually it wouldn't be. This is crazy. This is the solution point that's actually on there. Well, we have the gist of how to do it. I may change that example, we'll see. I'll probably just leave it. I think it's fine. Okay, perpendicular lines. Perpendicular lines have slopes that are opposite reciprocals of one another. Opposite reciprocals. So that means the sign of it's going to be opposite, and it's going to be the flip version. Perpendicular lines cross. They form a 90-degree angle when they cross. So this says, list the slope of a line that will be perpendicular to each slope given. So, first off, in this equation, what is the slope? It's negative 3. The perpendicular slope would be opposite, so it would be positive, reciprocal, which would be 1/3. So that's what I mean when I say opposite reciprocal. With this equation here, the slope of that is 2/3. Opposite reciprocal. It's a positive 2/3. I'm going to make it negative. That's what opposite means. And the reciprocal of 2/3 is 3/2. So that would be the perpendicular slope. Last one here. The slope of this would be 5. Opposite reciprocal would be negative, because that's positive, and the reciprocal of 5 is 1/5. So now that we know how to identify what the perpendicular slope should be, let's try a few examples of writing equations with perpendicular slopes. Turn your page. Okay, so the steps. Step 1 is still to identify the slope. And then we're going to take the opposite reciprocal of it. We're going to do the same thing we did before. We're going to plug in x1, y1. We're going to solve the equation for y, because I do want in the end all these to be written in y equals mx plus b form. Alright, so step 1, here we go. I want to write an equation for the line that passes through 1, negative 1, and is perpendicular to y equals 1/2 x plus 1. So in this equation, the slope is 1/2, the slope that's given. The slope I need to use is going to be the opposite reciprocal of that. So opposite sign would mean it's negative, because that one's positive. And the reciprocal of 1/2 is 2/1, or just plain old 2. And now the steps are exactly the same as the previous page. I'm going to take y minus y1. Remember, this is x1, this is y1. Equals the slope that I want, opposite reciprocal, times the quantity of x minus x1. And I'm going to keep change, and solve this for y. Add my negative 1, and y would equal negative 2x plus 1. Voila! So this equation here, if on your graphing calculator you typed in y equals 1/2 x plus 1, and you typed in negative 2x plus 1, and you pressed graph, you're going to see two lines that kind of form a plus sign, if you will. That's kind of what perpendicular looks like. There'll be right angles all over the place. Alright, another one of these. Write an equation that passes through negative 3, 7, and is perpendicular to y equals negative 2x minus 5. So the slope that's given by this equation is negative 2. The slope I want to use to write an equation that's perpendicular is opposite reciprocal. So opposite of negative is positive, so this is positive, and the reciprocal of 2 is 1/2. So I want the equation that I write to have a slope of 1/2, and negative 3 is my x1 and 7 is my y1. So we're going to use our point slope. Y minus y1 equals the slope times x minus x1. I'm going to keep change. So y plus negative 7 equals 1/2 x plus 1/2 times 3 would be 3/2. We can change it to 1.5 if you want. I'll give it a minute. And we're going to add 7 to each side. So y would equal 1/2 x plus, if you take 7 plus 3/2, which means 1.5, you get 8.5. So again, if on your graphing calculator you typed in y equals negative 2x minus 5, and you typed in 1/2 x plus 8.5 and press graph, you're going to see two lines that are perpendicular to one another. All right, last one of these. Write an equation of the line that passes through negative 3, 1, and is perpendicular to the line shown on the graph. Now I know you've been used to looking at an equation to find the slope. How on earth are we going to find the slope? All we have is a point here. I know my x1, y1. Geez, how do you find the slope of a line? Oh yeah, it's rise over run. So we can write an equation that's perpendicular to this line. We can find the slope. That's our step 1, right? So slope is the change in y over the change in x from any point on the line to another point on the line. So I'm just going to go from here to here. To get from here to here, we have to go down 1, 2, 3, 4. That would be a negative 4. And write 1. So that makes the slope of this line negative 4. Well, a perpendicular slope, the slope I actually need to use, is the opposite reciprocal of negative 4, which would be positive 1/4. So I want a slope of 1/4, and I want the point negative 3, 1 to be on there. So y minus y1 equals the slope times x minus x1. Keep change. All we have left to do is rearrange this lovely little problem. Y plus negative 1 equals 1/4 x plus, and 1/4 times 3, yes, that is 3/4. And we're going to add 1 to each side. Y will equal 1/4 x plus, if you take 1 plus 3/4, that would be 1 3/4 or 1.75, whatever you prefer. Either way, you are done. See you tomorrow.